The speed of light has never been broken. Not once. Not ever. But on April 29th, 2024, a small team in New York published something that made physicists stop and quietly ask, what if we had the wrong question this whole time? Not how do you break the speed of light, but what if the barrier was never actually a wall? What if it was always a door and we just found the handle? Tonight we are going to sit with that question together, and I promise it goes somewhere you are not expecting. If that sounds like your kind of evening, subscribe, get comfortable, because what comes next changes how you think about everything. Part 1. The paper that should have been front page news. Something happened on April 29th, 2024 that should have stopped people mid-scroll. It should have made headlines on every science publication from Nature to the front page of Reddit. It should have been the kind of news that gets texted between friends who don't even follow physics. The kind that makes your coworker lean over and say, "Did you see this?" It did none of those things. Instead, it landed quietly, almost invisibly, in the pages of a journal called Classical and Quantum Gravity, and the world mostly kept moving. That journal, by the way, is not an obscure one. It is one of the most respected publications in theoretical physics, and it holds a particular kind of historical significance for anyone who has ever spent time thinking seriously about the possibility of faster-than-light travel, because it is the same journal that 30 years earlier published a paper by a Mexican physicist named Miguel Alcubierre that genuinely changed how physicists thought about the geometry of space. If you know anything about warp drives, you know Alcubierre's name. His 1994 paper essentially opened a door that most scientists had assumed was permanently sealed. So when a new paper appears in that same journal, written by a team that claims to have done something nobody has managed to do in the 3 decades since, the quiet is strange. The quiet feels wrong. The team was led by Jared Fuchs, a physicist working at a privately funded research organization in New York called Applied Physics. Not NASA, not CERN, not a government laboratory with a $3 billion budget and a press office ready to announce discoveries to the world. A small, independent lab. The other authors were Alexei Bobrik and Yanni Martyr, and together they published something that, if you read it carefully, looks less like a routine academic contribution and more like the first crack in a wall that physics has been staring at since the middle of the 20th century. What they published was a solution to Einstein's field equations. That might sound dry, but stay with me for a second, because this is where it gets interesting. Einstein's field equations are the mathematical machinery that governs how matter and energy curve space-time. They are the deepest rulebook we have for understanding how the universe is structured at its most fundamental level, and for the last 30 years, every serious attempt to construct a warp drive using those equations had run into the same catastrophic wall. Every attempt required something that does not exist in nature as we understand it. It required what physicists call exotic matter, which is matter with negative energy density, matter that behaves in ways that nothing we have ever observed behaves. Every warp drive solution before April 29, 2024, was built on an ingredient that cannot be found in any laboratory, any star, any galaxy, anywhere in the observable universe. The equations allowed the geometry. The physics of actual matter made it impossible. What Fuchs, Bobrik and Martyr found was a configuration, a specific shape of space-time, that produces a genuine warp bubble while using only positive energy, only real matter, only stuff that actually exists, and not just barely. Their solution satisfies what are called the classical energy conditions, a set of 4 mathematical constraints that act as sanity checks for physical matter. If your solution violates the energy conditions, physicists know that whatever you have described is not something that can be made of real observable stuff. Every warp drive before this one failed those tests. This one passes all 4 simultaneously. Let that sit for a moment. In 30 years of research, with Alcubierre's framework sitting on the table, and dozens of brilliant physicists trying to improve on it, nobody had managed to build a warp bubble solution that uses only physical matter. This is the first one. This is the first time the equations have looked back at us and said, in their cold, indifferent mathematical language, this is allowed. Now there is a catch, and we are going to spend a lot of time with that catch later in this video, because it turns out the catch is not really a failure. The catch is that the bubble moves at subliminal velocity. It moves slower than the speed of light. If you came here hoping to hear that someone invented Warp 9 and we are all booking tickets to Alpha Centauri next Tuesday, I am going to have to disappoint you. There is no prototype. There is no experiment. There is no engine. This is a purely mathematical result. The warp bubble exists in equations, not in metal and propellant. But here is the thing you need to understand before we go any further. The fact that it is subliminal is not the story. The story is that for the first time in the history of this field, the story is allowed to exist at all. For decades, the question was not, how fast can a warp drive go? The question was, can a warp drive exist in a universe made of real matter? And for 30 years, the answer that kept coming back was, not with any matter we know of. The 2024 paper changes that answer. It says yes. It says the geometry is physically achievable, at least in principle, at least mathematically, with matter that obeys the same rules as everything else in the universe. The speed question, the question of whether it can ever cross the threshold into faster-than-light travel, comes after that. You cannot negotiate with a wall that will not open at all. The door just opened. There is something quietly beautiful about the way this discovery arrived. There was no press conference. There was no tweet thread that went viral with 10 million impressions. A small team at a privately funded lab published a peer-reviewed paper, and the mainstream media barely noticed. And I keep thinking about what that silence means. Either the world was not paying attention, which seems likely, or the world somehow intuited that this kind of physics is supposed to arrive quietly, the way most of the deepest shifts in our understanding always do. Relativity did not arrive with fireworks in 1905. Quantum mechanics was not a headline. The discoveries that change the rules have a habit of looking at first like small technical adjustments. This one might be in that category. It might also be something much more than that. So the question this video is going to sit with is not whether the speed of light has been broken, because it has not. Not yet. Not in this paper. The question is something more interesting than that. If this paper proves that the real barrier was never the speed of light but the requirement for impossible matter, and if that requirement has now been removed, even in a limited case, what has actually changed? What does it mean to call something a speed limit when the constraint that enforced it has just been dissolved? And why would the universe allow the geometry but seem to place a boundary at a specific velocity? What is the speed of light actually protecting? That last question is the one that will keep appearing throughout this video. Because once you start pulling on it, the speed of light stops looking like a wall and starts looking like something much more deliberate. Something more like a rule. And rules, unlike walls, can sometimes be navigated. What nobody has ever managed to do until this year is find a way to even stand at the door. Now finally, someone is standing there. The door is open a crack. And what we need to understand before we talk about what lies beyond it is why that door was so hard to find in the first place. Part 2. The assumption. Everyone got wrong. Here is the assumption that derailed 30 years of warp drive physics, and it was so deeply embedded in the conversation that most people never even noticed it was an assumption. The assumption was that the primary obstacle to building a warp drive was the speed of light, that the hard part was the going fast, that relativity had put up a wall at roughly 300 million meters per second, and the engineering challenge was to find a way to punch through it. That framing, that instinct to see light speed as the enemy, was almost universally held, and it was almost completely wrong. To understand why, you have to go back to 1994 and spend a little time with Miguel Alcubierre, who was at the time a PhD student at the University of Wales. Alcubierre had been watching an episode of Star Trek, which is either the most inspiring origin story in modern theoretical physics or a very on-brand beginning for a paper about warp drives, depending on your perspective. He started thinking about whether general relativity, Einstein's theory of how space-time curves in response to energy and mass, could in principle support the kind of faster-than-light travel that science fiction had been assuming for decades. The result of that thinking was a paper called The Warp Drive, Hyperfast Travel Within General Relativity, and it did something genuinely remarkable. It showed that the equations of general relativity do not, by themselves, prohibit faster-than-light travel. There is a configuration of space-time geometry, a specific way of warping the fabric of the universe around a small region that would allow an object inside that region to effectively travel faster than light relative to distant observers without ever locally exceeding the speed of light. The way the Alcubierre metric works is almost poetic in its simplicity once you strip away the mathematics. Imagine a bubble of flat space-time, and inside that bubble is your spacecraft. The spacecraft is not accelerating. It is just sitting there in its local environment, completely stationary relative to its immediate surroundings. But outside the bubble, space-time is being actively manipulated. Space contracts in front of the bubble and expands behind it. The bubble, and everything inside it, gets carried along by this wave of geometric distortion, the way a surfer gets carried by a wave without the surfboard ever having to push against the water with its own engine. The craft does not move through space. Space moves around the craft. This is a genuinely elegant idea. It bypasses the relativity problem because relativity only forbids matter from locally exceeding the speed of light, meaning you cannot accelerate a massive object through space faster than light. It says nothing technically about the speed at which space itself can move. In the Alcubierre solution, the spacecraft is always locally at rest. It is space that is doing the moving. So in the narrow technical sense, nothing in the equations of special relativity is violated. The craft never outruns light in its own neighbourhood. The neighbourhood itself just happens to be travelling faster than light relative to distant observers. If this sounds like a loophole, that is because it is. But it is a loophole that the mathematics of general relativity appears to permit. The problem, the one that immediately became apparent and that dominated warp drive physics for the next 3 decades, had nothing to do with the speed. The problem was the energy. To create the kind of space-time distortion that the Alcubierre metric describes, you need matter and energy arranged in a very specific way, and that arrangement requires what physicists call negative energy density. You need matter that has a negative amount of energy, matter that would, if placed on a scale calibrated to Einstein's equations, register below zero. No such matter has ever been observed in any usable macroscopic form. Negative energy density is not a minor engineering challenge. It is a category violation. It would require material that is fundamentally unlike anything in the known universe. The energy conditions I mentioned earlier are the formal way physicists codify this intuition. There are 4 of them that matter most in this context. The weak energy condition essentially says that the energy density of matter, as observed by any physical observer, must always be greater than or equal to 0. You cannot have negative energy density. The null energy condition says the same thing, but for observers moving at the speed of light. The dominant energy condition adds the requirement that energy cannot flow faster than light, which sounds redundant but has important geometric consequences. The strong energy condition governs how matter contributes to gravitational attraction. These 4 conditions, taken together, are not arbitrary restrictions. They are the mathematical fingerprint of matter that behaves like matter. They are the equations saying, this is what real stuff looks like. Alcubierre's solution violates them, not barely, not in some technically debatable way, but catastrophically. The amount of negative energy required to power an Alcubierre warp drive at faster than light velocities was calculated in the years after his paper, and the numbers were almost comically impossible. Early estimates suggested you would need something on the order of the mass-energy equivalent of Jupiter, in negative form, to produce a bubble large enough to contain a spacecraft. Later refinements, including work by Harold White at NASA's Johnson Space Center, brought those estimates down significantly. Chris van den Broek in 1999 found a clever modification to the bubble geometry that reduced the energy requirements by many orders of magnitude. But every single one of these solutions, no matter how carefully optimized, still required some negative energy. They all still violated at least one of the classical energy conditions. They were all, in the technical language of the field, unphysical. Mathematically consistent, but impossible to build. So the reason warp drive research stagnated between 1994 and 2024 was not because of the speed of a light, it was because of the matter. Physicists were not standing in front of a wall that said, you cannot go faster than light. They were standing in front of a supply closet that said, ingredients required, 1 planet mass of matter with negative energy density, properties unknown, location nowhere. Every design for a warp drive was essentially a recipe that called for an ingredient that does not exist. You can scale the recipe up or down, you can make the portions smaller, you can substitute here and there, but if the flour simply does not exist, the bread does not get baked. This is the reframing that the 2024 paper forces on the entire field. The speed of light was never the real obstacle. It was downstream of the actual problem. The actual problem was always, can you engineer spacetime geometry using only matter that obeys physical law? That was the question. Not can you go fast, but can you build anything at all? And for 30 years the answer was no. The best solutions available required exotic matter. The geometry was always real. The sourcing was always fictional. This matters enormously for how you think about the breakthrough. If you frame the problem as how do we break the speed of light, then the 2024 result looks like a near miss. It produces a warp bubble, but the bubble moves slowly. Disappointing. But if you frame the problem correctly, if you recognize that the real question was always whether physically sourced warp geometry is even possible, then the result looks completely different. It looks like the end of a 30-year drought. It looks like the first time anyone has ever made the flour. We are not yet baking bread. We are standing in a field looking at wheat, which is an extraordinary thing to be able to do for the very first time, and understanding what comes next requires understanding exactly what that wheat looks like and where it grew. Part 3, inside the first legal warp bubble. To understand what Fuchs and his team actually built, you need a small piece of context about how modern theoretical physicists test warp drive ideas, because it is not what most people would imagine. There is no laboratory, there is no prototype, there is a computer program. Specifically, there is a numerical relativity tool developed by the applied physics team called Warp Factory, and it is, in a very real sense, a physics simulator for exotic spacetime geometries. You feed it a candidate spacetime metric, a mathematical description of how space and time are curved in a particular region, and it evaluates that metric against Einstein's field equations and the classical energy conditions to determine whether the geometry is physically realizable. It is in essence a machine for asking the universe, is this allowed? To appreciate why a tool like that matters, you need a picture of what spacetime actually is in the context of general relativity. Think of spacetime as a four-dimensional grid, 3 dimensions of space plus 1 of time, and wherever there is energy or mass, that grid curves. A star bends the grid, a planet bends it less, a black hole bends it catastrophically. The equations that govern this relationship, Einstein's field equations, are what allow physicists to predict how matter will move through a given curved spacetime, and also, working in reverse, to ask, what configuration of energy and matter would produce a given curvature? Warp Factory works in that second direction. You describe the curvature you want, and it tells you whether the energy and matter required to produce it are physical. The specific solution that the team found in 2024 is built around what they call a stable shell of positive energy. Imagine a thin spherical shell, like a soap bubble but made of concentrated energy, surrounding an interior region of approximately flat spacetime. The craft, hypothetically, would sit in that flat interior, completely undisturbed, not accelerating, not experiencing any exotic forces. Outside the shell, the geometry of spacetime does what Alcubierre described. Space contracts in the direction of travel ahead of the bubble and expands in the region behind it. The geometry produces directed motion. The interior is carried along. This is the essential structure of any warp drive configuration. What is new here, and this is the part that changes everything, is that the shell itself is made of positive energy. Not negative energy, not exotic matter. Positive energy density, the kind that matter as we know it actually has. When the team fed their candidate metric into Warp Factory and evaluated it against the 4 energy conditions, the results came back clean. The weak energy condition, satisfied. The null energy condition, satisfied. The dominant energy condition, satisfied. The strong energy condition, satisfied. All 4 simultaneously everywhere within the geometry. For the first time in 30 years of this research program, the equations returned a result that said, this is physically possible, this is not fictional. The distinction between the interior and the exterior of the bubble is worth dwelling on for a moment, because it contains the deepest insight of the solution. Inside the bubble, spacetime is flat. The passenger or the crew, or whatever hypothetically occupies that interior, experiences no acceleration, no tidal forces, no sense of motion whatsoever. From their perspective, they are sitting still. The reason this matters is that it directly addresses one of the oldest objections to warp drive travel. The problem of how a biological organism could survive the enormous energetic processes required to distort space-time around it. If those processes are all happening in the shell, outside the flat interior, then the occupants are insulated from them. You are not riding the wave. You're inside a calm pocket that the wave is carrying. The ocean is doing the work, and you are sitting in a lifeboat at its centre. The craft in this framing provides no thrust. There is no engine burning fuel and pushing against something. The motion of the bubble, if it were ever built, would be entirely a consequence of the geometry of the shell and how it interacts with the surrounding space-time. This is so different from ordinary propulsion that it almost requires a different conceptual vocabulary. In ordinary rocketry, you accelerate by throwing mass backward. Your speed is always limited by how much mass you have and how fast you can throw it, and as you approach the speed of light, the energy required to continue accelerating grows without bound and eventually becomes infinite. That is the conventional barrier. In a warp drive, that barrier is irrelevant. You're not accelerating mass, you're shaping space. The energy cost is determined entirely by the geometry of the shell, not by your velocity relative to some external observer. This is why even the subliminal version of this result is a meaningful breakthrough. The energy conditions being satisfied means that, in principle, a physical mechanism exists that could produce directed space-time motion without the infinite energy cost of relativistic acceleration. Even if the bubble can only travel at, say, half the speed of light, it would do so with an energy budget that does not scale catastrophically with velocity the way conventional propulsion does. The traversal of interstellar distances, which is currently the fundamental problem for any serious space exploration, does not require you to reach the speed of light to benefit enormously from the absence of that runaway energy scaling. But here is the part that should make you lean forward. The Fuchs solution is the first physically sourced warp drive in history. It is the proof of concept that the category exists. And the natural next question, the one the paper itself carefully does not fully answer, is what happens when you start pushing on that bubble? What happens as the velocity approaches the speed of light? What does the geometry do? What do the energy conditions do? Is there a version of this solution that remains physical as the velocity increases? Or does the first sign of exotic matter appear exactly at the threshold of light speed, like a physical law enforcing itself at precisely the most inconvenient moment? That question is sitting at the edge of everything this paper establishes. And answering it requires understanding what the speed of light actually is and what it is actually doing. Part 4, the catch that changes everything. Let us be direct about the limitation, because being vague about it would misrepresent both the paper and the physics. The 2024 solution is subliminal. It moves slower than light. And no, it does not come close to the speed of light, at least not in the specific configuration described. The bubble exists, it is stable, it is physical, but it is not going to get you to Alpha Centauri before your coffee gets cold. The speed constraint is real. So why does it matter? What exactly has been achieved if the whole point of a warp drive is to go fast and this one does not? The answer requires a shift in perspective, a change in what question you're even asking. For 30 years, the field was stuck not on the speed problem, but on the existence problem. The question was not, how do we make it go faster? It was, can we make anything at all? A subliminal warp bubble is a physically real warp bubble. It is the first one. It is the existence proof that the category of physically sourced warp geometry is non-empty, and that changes the entire shape of the research program. Before this paper, warp drive physics was a theoretical curiosity with a fundamental obstacle that no one could see past. After this paper, warp drive physics is a field with at least one verified example that the math permits, and the question has shifted from is this possible to what are the parameters? Those are profoundly different questions. The second one is tractable. The first one was, for 30 years, not. There is a deeper reason the subliminal result matters, though, and it has to do with the energy cost of conventional travel at high velocities. In ordinary physics, the problem of interstellar travel is not just that you cannot exceed the speed of light. The problem is that approaching the speed of light requires exponentially increasing energy. Einstein's special relativity tells us that as an object, with mass accelerates toward the speed of light, its relativistic mass increases, which means it becomes harder and harder to accelerate further. The closer you get to light speed, the more energy you need, and as you approach it asymptotically, the energy required diverges toward infinity. You can get to 90% of the speed of light, but getting to 99% costs enormously more than getting to 90%. Getting to 99.9% costs more again. You never get to 100% because the energy cost becomes literally infinite. A warp drive, even a subliminal one, does not have this problem. The craft inside the bubble is not accelerating through space. It is stationary within the bubble. The bubble itself is being carried by the geometry of the space-time outside it, and while there are certainly energy costs associated with maintaining and directing that geometry, those costs are governed by the physics of the shell, not by the conventional relativistic mass increase of the craft. In principle, there is a pathway to high-velocity travel in which the energy requirement does not diverge as you approach some fraction of light speed. That pathway, if it can be realized, would be transformative for interstellar travel, even if the bubble never crosses the threshold into faster-than-light territory. Consider what that means practically. The nearest star system to Earth is Alpha Centauri, at approximately 4.2 light-years away. At the speed of conventional chemical rockets, the fastest we have ever launched a spacecraft, the journey would take roughly 75,000 years. Even at 1% of the speed of light, which is about 3 million meters per second, more than 100 times faster than anything we have ever built, the journey would take 420 years. At 10% of the speed of a light, it is 42 years. At 50%, around 8 years, still enough for significant time dilation effects, but within a human lifetime. At 90%, about 4.5 years. The difference between these scenarios, in terms of what they mean for human exploration of the cosmos, is almost incomprehensible, and the barrier between them has never been the physics of fast travel. It has been the energy cost of accelerating mass to those velocities conventionally. If a warp bubble can carry a craft at even a significant fraction of light speed, with an energy budget that is physically achievable rather than theoretically infinite, the entire picture of interstellar exploration changes, not in a generation, not next decade. But the math is no longer forbidden. That phrase, the math is no longer forbidden, is the thing to hold on to. Before April 29th, 2024, the math of physically sourced warp geometry was forbidden by the energy conditions. Every attempt to write it down produced something that violated physical law. Now one solution has been written that does not. The barrier that was always treated as the ceiling has turned out to be, at least in part, an artifact of the floor not being there. The floor is now there. But the speed of light still looms. The subliminal solution exists. The question of what happens at and beyond that threshold remains completely open. And to even begin answering it, you need to rethink what the speed of light actually is. Because most people, including most people who follow science closely, have a fundamentally incomplete picture of what that limit is doing and why it exists. It turns out the phrase, the speed of light, conceals at least 3 completely different phenomena, and only one of them is actually forbidden in the way most people assume. Part 5. There isn't one speed limit, there are 3. Here is something that does not get explained nearly often enough. When people talk about the speed of light as a cosmic speed limit, they speak as though it is one thing, one rule, one absolute prohibition. You cannot go faster than light. Full stop. But the actual physics is much more granular than that, and the distinctions matter enormously for understanding what the 2024 paper is actually claiming to do and what it is not. The first version of the speed limit, the one that applies most commonly in everyday scientific discussion, is about matter moving through space. Massive objects, objects that have rest mass, cannot accelerate to or beyond the speed of light within their local spacetime environment. This is a direct consequence of special relativity. As an object accelerates, its kinetic energy increases, and near the speed of light that energy increase becomes dominated by the increase in relativistic mass, which means you need more and more force to achieve smaller and smaller additional acceleration. At the speed of light itself, the required energy becomes infinite. You cannot get there. This is a hard local limit. It applies to electrons, protons, spacecraft, and anything else with mass in their immediate vicinity. Nobody disputes this one. The second version is about information, specifically about whether information or causal influence can travel faster than light. This is a subtler prohibition, and it is actually the deeper one. Even in scenarios where something appears to move faster than light, the question physicists ask is, Can that apparent faster-than-light motion be used to transmit information from one point to another faster than light would carry it? If the answer is yes, then you have a mechanism for violating causality, for sending signals backward in time from the perspective of some observers. This leads to paradoxes of the kind that tend to make physicists instinctively conservative about any claimed FTL result. This limit applies even to phenomena that are not matter in the conventional sense, and it is enforced not by the math of special relativity directly, but by the requirement that causes precede effects, what physicists call causality. The third version, and this is the one that people most commonly forget about entirely, is about the expansion of space itself. Space is not static, it is expanding, and it has been expanding since the beginning of the universe. The rate of that expansion is governed by the Hubble constant, and for galaxies that are sufficiently distant from us, the expansion of the intervening space means that those galaxies are receding from us at velocities that exceed the speed of light, not because they are moving through space faster than light, but because there is so much expanding space between us and them that the cumulative recession velocity, the rate at which the distance between us is increasing, exceeds light speed. This does not violate the first kind of speed limit because the galaxies are not accelerating locally. It does not violate the second because no information is being transmitted. The expansion of space is not a signal. It is just geometry changing. These three versions of faster-than-light behavior are completely different phenomena with completely different physical interpretations, and they are constantly conflated in popular discussions of the speed of light. The warp drive belongs in the third category, not the first. The Alcubierre metric and the Fuchs solution derived from it do not involve matter accelerating through space. They involve the geometry of space changing in a directed way. The craft inside the bubble is always locally at rest. It is the bubble, the geometric structure of space-time around the craft, that moves. This is the same category as cosmic expansion. It is metric expansion of space, just engineered rather than cosmic. This reframing is not a technicality. It is the entire conceptual point of the warp drive idea. Relativity does not forbid metric expansion. It cannot forbid it because metric expansion is exactly what the universe has been doing continuously since the Big Bang. What the energy conditions forbid is constructing a specific kind of metric expansion using unphysical matter, which is what every warp drive before 2024 required. What the 2024 paper shows is that metric expansion of the warp bubble type can be constructed with physical matter at subliminal velocities. So the barrier people think exists, the absolute prohibition on faster-than-light travel, is actually a composite of three separate constraints, only one of which applies straightforwardly to a warp drive. The first constraint, about matter moving through space, does not apply because the craft is stationary in its local environment. The second constraint, about information and causality, is the serious one, and it is the reason the subliminal limitation in the 2024 paper may be more than just a technical constraint. We will return to that. The third constraint, about space itself, is not a constraint at all for warp drives. It is the principle on which they operate. Understanding this separation is what allows you to take the 2024 paper seriously without claiming it has broken any physical law. It has not broken anything. It has located, for the first time, a physically realizable instance of geometry that was always theoretically allowed. The category it belongs to is not forbidden. It never was. What was forbidden was the specific sourcing with exotic matter. Remove the exotic matter requirement and you're not breaking rules. You're following them more carefully than anyone had managed to before. That is a very different thing from breaking the speed of light. It is more like discovering, for the first time, which parts of the rulebook you were misreading. Part 6. The universe already moves faster than light. There is a quiet irony in the fact that the geometry this paper describes is something the universe has been performing continuously for 13.8 billion years. The warp drive is not an alien technology or a science fiction invention grafted onto real physics. It is, in a very real mathematical sense, a localized and engineered version of something the cosmos does naturally and continuously, and on a scale that makes any human engineering ambition look like a child drawing a circle and calling it the sun. Cosmic expansion is the context. Since the moment of the Big Bang, space has been expanding, meaning the distance between objects that are not gravitationally bound to each other has been increasing. This expansion does not require anything to move through space. Space itself is growing. The metric, the mathematical description of distances, is changing over time. In the language of general relativity, the scale factor of the universe, the number that describes how stretched out space is at any given moment, is continuously increasing. Objects that are not gravitationally bound to each other are carried apart by this expansion, the way raisins in a rising bread loaf are carried apart not because the raisins are moving, but because the dough between them is growing. At sufficiently large distances, this expansion produces recession velocities that exceed the speed of light. The Hubble constant, which currently sits at approximately 67 to 74 kilometers per second per megaparsec, depending on which measurement you trust, a tension in cosmology that is itself worth an entire video, means that for every megaparsec of distance between two objects, those objects are receding from each other at 67 to 74 kilometers per second. A megaparsec is about 3.25 million light-years. The Hubble sphere, the distance at which recession velocity equals the speed of light, is approximately 14 billion light-years from Earth. Everything beyond that sphere, which is a substantial fraction of the observable universe, is receding from us faster than light right now. We can still see it because the light from those regions was emitted when they were closer, but they are moving away from us at superluminal recession speeds as you read this. Nobody considers this a violation of physics. It is simply what an expanding universe does. Now go further back in time, to the first fraction of a second after the Big Bang, to the period cosmologists call inflation. During cosmic inflation, the universe expanded at a rate that was not merely superluminal, but hypersuperluminal by any measure that makes sense to imagine. In an extraordinarily brief window of time, estimates vary, but the canonical figure is something like 10 to the power of negative 32 seconds. The observable universe expanded from a region smaller than a proton to something roughly the size of a grapefruit. That is an expansion of something like 10 to the 26 in linear scale. The rate at which distances were increasing during that period was so far beyond the speed of light that the comparison essentially loses meaning. And yet inflation is a cornerstone of modern cosmology. It is not a violation of physical law, it is metric expansion, the same kind of geometry that the Alcubierre metric and the Fuchs solution describe. The mathematical connection between cosmic expansion and warp drive geometry is not a metaphor. It is a formal equivalence. The Friedmann-Lemaitre-Robertson-Walker metric, which describes the expanding universe in general relativity, and the Alcubierre metric, which describes the warp bubble, both belong to the same family of solutions to Einstein's field equations. They are both descriptions of spacetime where the metric, the geometric structure that defines distances and times, changes dynamically. The difference is scale. Cosmic expansion is happening everywhere, uniformly to the entire universe. A warp bubble, in principle, would be a localized region where that same kind of metric change is happening in a directed, controlled way. If the universe can expand at superluminal rates, the question the warp drive asks is, can you engineer a small pocket of that behavior? What the 2024 paper shows is that at least the subluminal version of that pocket can be described with physical matter. The universe already proves the geometry is real. Nature already demonstrates that metric expansion exists and operates at all scales. The question has always been whether it can be controlled, whether it can be made local, directed, and practical. The Fuchs result is the first mathematical confirmation that at least a slow version of that pocket can be described without requiring anything nature does not already provide. Space has always been the loophole. The 2024 paper is the first engineered description of a process the universe has been running since the first instant of time. Part 7. The quantum side door that does not open. There is another place people sometimes look when they start thinking about faster-than-light possibilities, and it is worth addressing briefly, because the confusion is common, and because understanding why it does not work actually clarifies something important about why the warp drive approach might. Quantum entanglement. Two particles can be prepared in what is called an entangled state, a state where measuring a property of one particle instantaneously determines the same property of the other particle, regardless of the distance between them. The effect is genuinely non-local. It does not attenuate with distance. An entangled pair separated by a meter and an entangled pair separated by a light-year behave identically, and the correlation appears instantly, faster than any light signal could have carried information between the two particles. This sounds, at first pass, exactly like what you would want for faster-than-light communication. You have two entangled particles. You give one to a person on Earth and send the other to a person on a spacecraft at Alpha Centauri, and you use the correlations to transmit information instantaneously across 4 light years. The problem is that you cannot do it. The no communication theorem, one of the most robust results in quantum mechanics, proves rigorously that quantum entanglement cannot be used to transmit information faster than light. The reason is subtle but important. When you measure your entangled particle, you get a random result. You cannot control what outcome your measurement gives. Your partner at Alpha Centauri also gets a random result. The correlations between those random results are real and non-local, but neither party can exploit those correlations to encode a message, because neither party can control the outcome of their measurement. The randomness is irreducible. This is the key contrast with the warp drive approach. Entanglement gives you correlations you cannot control. A warp bubble, in principle, gives you directed motion you can control. The entanglement path to FTL communication is a wall dressed up as a door. The warp geometry path is a wall that the 2024 paper suggests might actually be a door with a key, even if the key only opens the subliminal side of the door so far. Quantum entanglement is not a faster-than-light communication channel. It is a demonstration that the universe has non-local correlations while simultaneously ensuring those correlations cannot be weaponized for signaling. The universe apparently is precise about which rules it allows to be bent. Part 8. Every breakthrough that was not. Before we continue building on the 2024 result, we should spend a moment acknowledging the graveyard. The history of faster-than-light claims is not a short one, and almost every entry in that history ended the same way, with a retraction, a revised measurement, or a quiet disappearance. The M drive is probably the most recent prominent example. It was a proposed propulsion system that appeared to generate thrust without any propellant, which would itself have been extraordinary regardless of any faster-than-light claim, and for several years in the 2010s it generated genuine scientific interest and a small amount of careful experimental testing. The problem was that as the experimental methodology improved, the measured thrust shrank. By the time proper electromagnetic shielding was applied to the test apparatus, the thrust disappeared entirely. What had been measured was thermal artifact, electromagnetic interference between the drive and its own testing environment. The M drive never moved anything. It generated papers, though, which is its own kind of monument. The opera neutrino result from 2011 was perhaps the most dramatic false alarm. A collaboration of physicists at CERN measuring the travel time of neutrinos from Geneva to the Gran Sasso laboratory in Italy reported, to their own considerable surprise, that the neutrinos appeared to arrive approximately 60 nanoseconds faster than light would have covered the same distance. The result passed multiple internal checks. The team reported it publicly while explicitly inviting scrutiny. That scrutiny eventually identified 2 instrumental problems, including a faulty fiber optic cable connection that accounted for the anomalous timing. When those were corrected, the neutrinos arrived exactly when they should have. Light speed remained intact. What distinguishes the 2024 paper from these examples is not that it claims something more dramatic, it is that it claims something more careful. It does not assert faster-than-light travel. It does not report an anomalous measurement that exceeds known physics. It describes a mathematical solution to Einstein's equations that satisfies all established energy conditions and produces a result that is slower than light. It survives peer review in one of the most respected journals in the field. It is not a claim that breaks physics. It is a claim that follows physics more completely than previous attempts and arrives at a physically realizable result for the first time. Skepticism is always warranted, and the gap between a mathematical solution and an engineered device is enormous. But this is different from every previous faster-than-light story. Those change the constraints. This one works within them. Part 9. The hidden cost of faster-than-light. Now we arrive at the part of the story that most popular accounts of warp drive physics skip past, and it is the part that arguably matters most for understanding why the speed of light exists as a limit in the first place. Because here is the thing. The speed of light is not primarily a constraint about speed. It is a constraint about time, and the moment you start seriously engaging with that realization, the entire problem of faster-than-light travel changes character. The person who first made this connection rigorous in the context of warp drives was not Alcubierre, but a physicist named Alan Everett, who in 1996 published a paper analysing the causality properties of the Alcubierre metric. His finding was uncomfortable. Warp drive at superluminal velocities does not just allow you to travel faster than light, it allows you to travel backward in time, not as a side effect, not in some exotic limiting case, as a direct mathematical consequence of what superluminal metric travel means in the framework of special and general relativity. To understand why, you need to think about simultaneity. In special relativity, whether two events are simultaneous, whether they happen at the same time, is not a universal fact. It depends on the motion of the observer. Two events that appear simultaneous to a stationary observer may appear to happen in different orders to an observer in motion. This is not a philosophical confusion about perception. It is a geometric fact about the structure of space-time. The mathematical machinery that governs this is the Lorentz transformation, and it has been tested with extraordinary precision. Now here is the consequence. Suppose you have a faster-than-light warp drive, and you travel from Earth to a distant planet in what appears, to you and to observers at Earth, to be a very short time. From the perspective of an observer moving in a different direction at high velocity relative to you, the order of your departure and arrival can be reversed. From that observer's perspective, you arrived before you left. This is not a trick of perception or a measurement artifact. In the framework of special relativity, what is simultaneous for one observer is not simultaneous for another, and superluminal travel crosses the boundary in space-time, where the temporal ordering of events becomes frame-dependent. Matt Visser, one of the most careful analysts of exotic space-time geometries in the field, extended this analysis to show that a sufficiently advanced civilization with access to multiple warp drives, or even with the ability to use one warp drive on two separate trips, could construct what physicists call a closed time-like curve. A closed time-like curve is a path through space-time that loops back on itself in time. An observer following such a path would eventually arrive at a point in their own past. That is not metaphor. It is the mathematical content of a closed time-like curve, and it is a direct consequence of superluminal travel in general relativity. The grandfather paradox, the classic thought experiment in which you travel back in time and prevent your own grandparents from meeting, is one illustration of why closed time-like curves are so troubling. If you can influence your own past, then the causal structure of the universe collapses. Causes no longer necessarily precede effects. The entire logical scaffolding on which physics is built, the assumption that the present state of the universe is determined by past states and not by future ones, begins to unravel. And this is the deeper reason the speed of light is a limit. It is not protecting the universe from going fast, it is protecting the universe from going backward. This insight, that the speed of light limit is fundamentally a protection of causality, rather than a constraint on velocity, reframes everything. The speed of light is the velocity at which the causal structure of the universe is maintained. Below light speed, causes precede effects for all observers. At and above light speed, the ordering of events becomes frame-dependent, and with the right configuration of motion and geometry, that frame dependence allows for causal loops. The universe appears to have a very strong preference against causal loops. Everything we observe is consistent with causes preceding effects. The speed of light is the boundary where that consistency is preserved. So when you ask, can we break the speed of light, the physics is asking back, do you want to break time? That is the real question embedded in the speed limit, and it is the reason that the causality problem is not going to be solved by better engineering. It is not an engineering problem, it is a logical one. If faster-than-light travel implies the possibility of closed time-like curves, and if closed time-like curves allow you to influence your own past, then the universe may have very deep reasons for not permitting them that have nothing to do with the strength of exotic matter or the efficiency of your drive system. Part 10. Why the 2024 paper stopped short. The subliminal constraint in the Fuchs solution is starting to look less like a limitation and more like a feature. And understanding why requires one more physicist, one whose name you almost certainly know, and whose contribution to this specific problem is probably the least discussed thing he ever did. Stephen Hawking. In 1992, 2 years before Alcubierre published the warp drive metric that started all of this, Hawking proposed what he called the chronology protection conjecture. The conjecture, which remains unproven as a formal theorem but has held up remarkably well against 3 decades of theoretical challenges, states something that sounds almost philosophical until you sit with the mathematics behind it. It states that the laws of physics conspire to prevent the formation of closed time-like curves. In other words, the universe protects its own causal structure. Not as a preference, not as a tendency, as an active, apparently self-enforcing property of physical law. What that means in practice is this. Any attempt to build a time machine, whether through the frame-dragging geometry of a rotating black hole, the exotic topology of a traversable wormhole, or the superluminal version of a warp drive, will be thwarted by some mechanism before it can actually close the causal loop. The mechanism might be quantum effects, it might be a catastrophic instability of the geometry itself, it might be something we have not fully characterized yet. But Hawking's claim was that whatever the mechanism turns out to be, it will always be there, waiting at precisely the moment it is needed. The universe, in this picture, is not passively structured in a way that makes time machines hard to build. It is actively structured in a way that ensures they never quite work. Now, Hawking's conjecture is not a proven theorem. It is important to say that clearly. It is a physical intuition, a very well-developed and carefully reasoned one, backed by several compelling calculations. But it has not been derived from first principles in a way that would satisfy a mathematician demanding a complete proof. What it has going for it is something different. Every time someone has looked carefully at a proposed mechanism for closing a causal loop, the physics has found a way to prevent it. Not always elegantly, not always through a clean, satisfying argument, sometimes through what looks almost like the universe reaching into its toolbox and pulling out exactly the right catastrophe at exactly the right moment. The most important of those calculations involves what happens to quantum fields when a closed time-like curve is about to form. The quantum vacuum, which sounds like it should be nothing but is in quantum field theory, a seething background of virtual particles and fluctuating energy, does not sit quietly near an incipient causal loop. When physicists analysed what happens to vacuum energy in the vicinity of a space-time geometry that is on the verge of closing a time-like curve, the results were dramatic. The quantum vacuum energy diverges. It does not become large. It does not become uncomfortably elevated. It blows up. It becomes infinite, and it does so precisely at the moment and location where the causal loop would close. That divergence is not a mathematical artifact or a sign that the calculation broke down. It is a physical signal. It means that an infinite amount of energy floods into the geometry at exactly the moment it would become a time machine, and that energy destroys the delicate space-time configuration required for the loop to exist. Think about what that actually means. The universe does not prevent time machines by making them mathematically impossible to describe. You can write down the mathematics of a closed time-like curve. The equations allow it. The description is coherent on paper. What the universe does instead is allow the mathematics to be written, and then, at the physical level, ensure that the energy conditions in the quantum vacuum make the actual realization of that geometry self-terminating. It is less like a law that says you cannot, and more like a law that says every time you try, the floor will give way beneath you at exactly the critical moment. The prohibition is enforced not through logical impossibility, but through physical catastrophe. The universe apparently has very sophisticated opinions about time travel, and it expresses them not in the language of elegant prohibitions, but in the language of infinite energies and collapsing geometries. Now bring this back to the warp drive, because this is where Hawking's conjecture does something very specific and very consequential to the problem. If the chronology protection conjecture is correct, it draws a line in the solution space of warp drive physics. Below the speed of light, the geometry of a warp bubble is physically realizable, causally safe, and, as the 2024 paper demonstrates for the first time, mathematically consistent with real matter obeying real energy conditions. The space-time configuration is stable. The causal structure of the universe is preserved. Causes precede effects for all observers. Nothing about the subliminal bubble threatens the temporal ordering of events. You are moving, potentially very quickly, but you are moving forward through time in a way that every observer in every reference frame would agree on. Above the speed of light, everything changes. The superluminal version of warp bubble geometry does not just move fast. As Alan Everett showed in 1996, it generates closed, time-like curves, not as a side effect in some exotic limiting case, but as a direct mathematical consequence of what superluminal metric travel means in general relativity. The chronology protection conjecture, then implies that those curves are unstable, that the quantum vacuum energy would diverge and destroy the configuration before the causal loop could close. The speed of light in this framing is not primarily a velocity limit. It is the boundary between the causally safe region of warp drive physics and the causally dangerous one. Below it, the geometry is allowed and stable. Above it, the geometry may be describable on paper, but is physically self-terminating. This reframing makes the 2024 result look almost deliberate in its restraint, as though the solution was not just the first physically sourced warp bubble, but the first one that knew where to stop. By producing a configuration that is strictly subliminal, Fuchs and his team have staked out the region of the theory that is simultaneously physically realizable, energetically sourced with real matter, and causally safe. They have not just found the first floor of the building, they have found the first floor that is not on fire. Everything above a certain height in this metaphor might be structurally unstable in ways that physics itself prevents you from occupying. Not because the architecture is incomplete, but because the universe has apparently decided, at the level of quantum field theory, that those upper floors are not for habitation. The ground floor in this picture is not a consolation prize. It is the first stable region that has ever been identified, and stable regions are where engineering begins. You cannot build on a foundation that collapses. You cannot develop a technology on the basis of a physics that self-destructs. The subliminal warp bubble is the first result in 30 years that has a foundation underneath it, a foundation made of physical matter, satisfied energy conditions, and a location in parameter space that the chronology protection conjecture does not threaten. Whether that foundation can be extended, whether there is a way to approach the light speed boundary from below while remaining on stable ground, is an open question. But open questions with a stable starting point are a completely different kind of problem from open questions that have no stable starting point at all. There is something genuinely strange about the picture this paints of the universe. The geometry that allows directed, controlled metric expansion, the geometry of warp drives, is not forbidden. The universe permits it. The equations support it. The energy conditions, at least in the subliminal regime, can be satisfied with physical matter. The universe is, in this sense, more permissive than the last 30 years of failed attempts suggested. But the version of that geometry that would allow you to loop back through time, to arrive before you departed, to influence your own past, is apparently self-terminating in a way that does not require a formal prohibition. The quantum vacuum handles it. The divergence arrives. The geometry collapses. The universe enforces its preference for causal order not through an elegant "thou shalt not" written into the axioms, but through a catastrophic "and here is what happens if you try" written into the dynamics. For the 2024 paper, this means that the subliminal result is not just the first result. It may be sitting precisely at the edge of what the universe genuinely permits, not because the authors chose conservatively, not because they lacked the mathematical tools to push further, but because the deeper physics of causality and quantum chronology protection enforces that boundary from the other side. The math is no longer forbidden in the subliminal regime, but the frontier of the math, the boundary region where subliminal geometry approaches and crosses into superluminal territory, is surrounded by a warning that the universe itself appears to have written. That warning is not in words, it is in infinite vacuum energy densities and self-destroying geometries. It is the universe's way of saying, this far, and here is what happens next. How far that frontier can be pushed, whether it can be approached asymptotically, whether quantum gravity effects might rewrite the rules near the boundary in ways that classical general relativity cannot predict, and whether the warning can ever be safely navigated or whether it represents a genuinely absolute limit, dressed in the language of dynamics rather than prohibition. These are the questions that will define the next chapter of this research. The door is open. The first floor is stable, and somewhere above, the universe has installed a mechanism that may or may not be a ceiling. Finding out which it is might be the most important physics experiment of the next 100 years. Part 11. What happens next? The real frontier. If you want to understand where this field goes after 2024, you have to sit with the gap between what has been achieved and what would need to be true for it to matter practically. What has been achieved is a mathematical solution, a configuration of space-time geometry sourced by physical matter that satisfies every classical energy condition and produces a genuine warp bubble. That is not nothing. That is, in fact, the most significant result in this field in 30 years, but a mathematical solution is not a physical mechanism. It is not an engine. It is not a blueprint. It is a proof that the blueprint is not forbidden, which is a different and earlier thing. The gap between those two, between the proof of permissibility and the engineering of actuality, is enormous. The honest answer is that nobody knows how wide it is in units of time or resources or technological capability. But here is what I want to push back on slightly. Enormous gaps are not the same as featureless ones. There are specific directions already visible from where we are standing, specific physical phenomena and theoretical tools that are already pointing toward the questions the field will need to answer next. And some of them are strange enough and real enough that they deserve more than a passing mention. The first one is the Casimir effect, and if you have not encountered it before, it is one of those results that sits at the intersection of quantum mechanics and everyday physical reality in a way that should permanently change how you think about empty space. The setup sounds almost trivially simple. Take two flat, uncharged metal plates, place them very close together in a vacuum. According to classical physics, nothing should happen. There is no charge, no magnetic field, no obvious force between them. And yet the plates attract each other. They experience a real, measurable force, one that has been confirmed experimentally to extraordinary precision, with the most careful modern measurements matching the theoretical prediction to within a fraction of a percent. The reason this happens is one of the genuinely strange gifts of quantum field theory. Empty space is not empty. The quantum vacuum, the baseline state of a quantum field when no particles are present, is not a quiet, featureless void. It is a constantly churning background of virtual particle pairs, particles and antiparticles that pop into existence and annihilate so quickly that they cannot be directly detected, but whose collective presence has real, measurable consequences. In free space, virtual particles of all possible wavelengths are present, but between two closely spaced metal plates, the geometry of the gap restricts which wavelengths are permitted. Only wavelengths that fit within the gap are allowed between the plates, while outside the plates, the full spectrum continues uninterrupted. That asymmetry, more vacuum energy outside than between, creates a pressure imbalance. The plates are pushed together by the difference. The vacuum itself is generating a force. Now, why does any of this matter for warp drives? Because the Casimir effect is direct experimental evidence that the energy density of the quantum vacuum can be locally modified by geometry. Between the plates, the vacuum energy is lower than it is in free space. That local reduction in vacuum energy density is, in the language of effective quantum field theory, a form of negative energy density, at least relative to the surrounding vacuum. Whether this constitutes the specific kind of negative energy that older warp drive solutions required is genuinely contested, and the honest answer is that the scales involved are nowhere near what any warp drive design has ever called for. The Casimir force between two plates separated by a micrometer is on the order of a few millinewtons per square meter. The energy scales relevant to warp geometry are many, many orders of magnitude larger. This is not a solution. Nobody should walk away from this paragraph thinking the Casimir effect is secretly a warp drive. But it is a pointer. It is experimental proof that quantum field theory allows geometrically induced modifications to the local energy density of the vacuum in ways that the classical energy conditions do not anticipate and do not fully govern. The Fuchs solution satisfies the classical energy conditions. Those conditions describe what physical matter looks like at the classical level. But quantum field theory operates at a deeper level than classical field theory, and the rules that govern energy densities in quantum field theory are not identical to their classical counterparts. There is a regime of physics, somewhere between the confirmed reality of the Casimir effect at micrometer scales and the speculative engineering of a warp bubble at spacecraft scales, where the classical energy conditions may give way to quantum-corrected conditions that are more permissive in ways we do not yet fully understand. The Casimir effect is a confirmed experimental foothold in that regime. It proves the regime exists. How far it extends and what can be done within it is a live and active area of research that the 2024 result makes significantly more urgent. The second direction worth examining carefully is the work of a physicist named Katie Clore, and her approach is different enough from the engineering-focused perspective that it is worth pausing to appreciate what she is actually doing, because it is not obvious at first glance why it matters. Clough is not trying to build a warp drive. She's not calculating energy requirements or stability conditions. She's developing what physicists call theoretical templates for gravitational wave signatures that a warp bubble, if one ever formed and then collapsed, would produce. To understand why that matters, you need the context of what gravitational wave astronomy has become since the first detection by LIGO in September 2015. Gravitational waves are ripples in spacetime itself, produced when massive objects accelerate or when spacetime geometry changes rapidly. When two black holes spiral together and merge, the collision sends gravitational waves outward at the speed of light, and those waves carry information about the geometry of the event that produced them. LIGO and its European counterpart Virgo are now sensitive enough to detect gravitational waves from events involving black holes and neutron stars billions of light years away. The signals are extraordinarily faint by the time they reach Earth, stretching and compressing space by less than 1,000th of the diameter of a proton, and yet the detectors find them. Clough's reasoning is straightforward but important. If a warp bubble were to form naturally, perhaps in some extreme astrophysical environment we have not yet characterized, and then collapse, the rapid change in the spacetime geometry would produce a burst of gravitational waves with a distinctive signature. Not the signature of a merging black hole, which has a characteristic chirp shape that theorists have calculated in great detail. Something different. Something that carries the geometric fingerprint of a warp-like spacetime structure. What Clough is building is the theoretical framework that would allow gravitational wave observatories to recognize that fingerprint if it ever shows up in the data. She is not engineering a warp drive. She is building the instrument to notice if the universe ever makes one on its own. That framing is worth sitting with for a moment. The possibility that warp-like geometries could form naturally, without any human engineering, is not as exotic as it sounds. The universe produces extreme spacetime geometries all the time, in the vicinity of neutron stars, near the ergospheres of rotating black holes, in the cores of collapsing massive stars. Whether any of these environments could produce a localized metric expansion, resembling a warp bubble, even briefly, even partially, is an open question, but it is a question that could in principle be answered observationally. And the observational infrastructure, the global network of gravitational wave detectors, already exists and is improving rapidly. Clough's work is the theoretical bridge between the mathematical results of the 2024 paper and the possibility of finding empirical evidence for warp-like physics in astrophysical data. That is a genuinely new avenue, and it did not exist before the Fuchs result gave it a mathematical foundation to stand on. The engineering challenges, even setting aside all of this and asking only about the practical requirements of building the simplest possible subliminal warp bubble, are formidable in a way that is worth being honest about rather than glossing over. The energy required to maintain a warp shell of even modest size is likely to be orders of magnitude beyond anything humanity currently produces or can currently imagine controlling. The stability question, whether small perturbations to the shell geometry would cause it to collapse or grow uncontrollably, has not been fully resolved by the paper. The initiation problem, how you would create the bubble in the first place, is untouched. The termination problem, how you would turn it off in a controlled way, is equally open. The habitability question, whether the interior remains a safe environment for a crew during operation, depends on details of the geometry that have not been worked out. These are not small gaps. They are entire research programs, each one potentially decades of work. But here is the thing about that list of open problems. Every single one of those questions has just moved from the category of premature to the category of next. Before 2024, asking about the stability of a physically sourced warp shell was like asking about the aerodynamics of a material that does not exist. The question had no traction because the foundation was not there. Now, the foundation is there. Every one of those engineering and theoretical questions now has a real solution to be the question about. That is the shift. Not that the problems are solved, but that they are now problems rather than premature speculations. The timeline for practical application remains genuinely uncertain in a way that anyone claiming precision about is probably being dishonest. Decades is optimistic. Centuries is probably more realistic. But consider this. In 1903 at Kitty Hawk, two bicycle mechanics from Ohio flew a powered aircraft for 12 seconds over a distance of 37 meters. 66 years later, humans stood on the moon. The Wright Flyer and the Saturn V rocket are separated by 66 years and by a gap in capability that is almost incomprehensible to describe, and yet the line between them is straight and unbroken. The history of technology does not extrapolate smoothly from the present, because the present never fully anticipates what discovery does to the trajectory. What has changed as of April 29th, 2024 is precisely this. For the first time in 30 years, the physics of warp geometry is no longer waiting at a dead end. The road exists. Where it leads, and how long it takes to walk, is now an open and genuinely live scientific question. That is not a small thing. That is everything. Part 12. A wall, a contract, or a coincidence? We have been building toward this for the entire video, and now it is time to sit with the question that the 2024 paper actually opens. Not the engineering question, not the timeline question, but the interpretive one. The one that does not have a clean answer yet and may not have one for a very long time. What is the speed of light? Not in the textbook sense, not the number, not the units, but what is it actually doing in the structure of the universe? What role does it play? Is it a feature of reality, the way the number of spatial dimensions is a feature of reality, something so fundamental that asking why it exists is like asking why mathematics is consistent? Or is it something more contingent, more local, more dependent on conditions that could in principle be different? Because depending on how you answer that question, the significance of the 2024 paper is completely different. And the three possible answers are not just different opinions, they are genuinely different pictures of what kind of universe we are living in. The first answer is that the speed of light is a wall, an absolute, fundamental, uncircumventable limit on the propagation of matter and information through the universe. In this picture, the barrier is not an artifact of our current technology or a gap in our mathematical sophistication. It is a structural feature of space-time itself, baked into the geometry of reality at a level so deep that no engineering, however advanced, and no mathematical cleverness, however elegant, can circumvent it. The analogy that works best here is not a physical wall that could in principle be demolished with enough force. It is more like the constraint that prevents a triangle drawn on a flat plane from having interior angles that sum to more than 180 degrees. That is not a rule someone imposed. It is not an engineering limitation. It is a consequence of what flat geometry is. You cannot negotiate with it. You cannot find a clever way around it. The triangle simply cannot have those angles because of what the words flat and triangle mean together. In this picture, the speed of light is that kind of constraint. It is the maximum causal propagation speed of the universe, not because someone wrote it into the rules from outside, but because it is what the structure of space-time implies, the same way the triangle's angle sum is what Euclidean geometry implies. The 2024 result is significant in this interpretation, genuinely significant, but its significance has a ceiling. The subliminal warp bubble is real. The door is open a crack, but the door only opens inward, into the subliminal region, and the room beyond, the superluminal regime, is not inaccessible because we lack the engineering. It is inaccessible because of the architecture of reality. The speed of light, in this first interpretation, is a load-bearing wall, and there is a reason you do not remove load-bearing walls. The building falls down. In this case, the building is causality, the logical structure that ensures causes precede effects, and the falling down is the formation of closed time-like curves, causal loops, and all the paradoxes that come with them. The wall is not arbitrary, it is holding something up. If this first interpretation is correct, then the 2024 paper represents the best possible outcome within the constraints. A physically sourced warp bubble that moves at subliminal velocities, potentially offering a pathway to high-speed interstellar travel without the infinite energy cost of relativistic acceleration, is enormously valuable even if it never crosses the threshold into faster-than-light territory. The wall stands, but there is a lot of useful territory on this side of it that we had not previously mapped. The second answer is that the speed of light is a contract, not an absolute prohibition written into the axioms of reality, but a description of the terms under which matter and information operate within the current configuration of the universe. This is a more lawyerly picture, and I mean that in the most technically precise sense. In this interpretation, matter is bound by the speed of light the way a tenant is bound by a lease. The terms are real, they are enforceable, Violating them has consequences, but they are not the laws of logic. They are the laws of a specific arrangement, the specific configuration of space-time and quantum vacuum that we happen to inhabit, and they apply to specific things. They apply to matter moving through space. They apply to information propagating through a medium. They do not apply, at least not in the same way, to the medium itself. This is the clause that warp-drive physics has always been trying to find and exploit. The speed of light limits how fast matter moves through space. It says nothing, directly, about how fast space moves relative to other space. The Alcubierre metric, and the Fuchs solution derived from it, do not involve matter accelerating through space. They involve the geometry of space changing in a directed way, with matter inside the bubble carried along as a passenger, rather than an accelerating object. The craft never locally exceeds the speed of light. The bubble, the geometric structure of space-time, moves, and the contract in this interpretation has a clause that covers matter and information but not geometry. The warp drive in this second picture is not a violation of the contract. It is an exploitation of a clause that was always present in the fine print, a clause that general relativity itself contains, because general relativity is precisely the theory of how geometry changes dynamically. The theory that describes matter curving space-time is also, by extension, the theory that describes directed metric expansion. The two are the same framework. The contract and the loophole are written in the same document. What the 2024 paper does, in this interpretation, is provide the first physically sourced example of a clause that exploits the distinction between matter moving through space and space itself moving. It is the first time anyone has cited that clause correctly, with matter that actually exists in a configuration that the full energy condition analysis approves. In this second picture, the door does not just open a crack, it opens, in principle, all the way. The subliminal result is not the final answer, it is the first key. The causality constraints that Alan Everett and Matt Visser identified, the closed time-like curves that emerge from superluminal warp travel, are not prohibitions in this interpretation. They are engineering challenges, extraordinarily difficult ones, possibly insurmountable ones with any technology we can currently envision, but challenges that live in the domain of physics rather than the domain of impossibility, which means they are in principle the kind of thing that could be approached, studied, and potentially navigated. The contract has terms. The terms are real. But contracts can be amended when both parties understand them well enough, and we're just beginning to understand the terms well enough to read them correctly. The third answer is the strangest of the three, and I want to be honest that it is also the most speculative. But it is coherent enough, and has been taken seriously enough by serious physicists, that it deserves a full and fair hearing rather than a dismissive footnote. What if the speed of light is a coincidence? Not in the trivial sense of being an arbitrary number that could have been different by chance, but in the technical sense that the specific value of the speed of light in vacuum might not be a fundamental constant of the universe at the deepest level. It might instead be a feature of the current state of the universe, the way the temperature of the cosmic microwave background is a feature of the current state of the universe. Real, measurable, consistent everywhere we can observe, but not fixed eternally. Different in the past, potentially different in the future, potentially different in different regions under different conditions. This idea goes by the name of varying speed of light cosmology, or VSL, and it is not a fringe idea in the sense of being scientifically disreputable. It has been developed seriously by physicists including John Barrow at Cambridge and Jerome Magejo at Imperial College London. Their argument, developed in detail in the late 1990s and early 2000s, is that the standard cosmological model faces certain puzzles, particularly the horizon problem and the flatness problem, which are conventionally solved by the theory of cosmic inflation. But inflation is not the only possible solution. If the speed of light was enormously higher in the first instance after the Big Bang, the early universe's causal structure would have been completely different. Regions that in the standard model could never have been in causal contact, and therefore should show wildly different temperatures and densities, would have been able to exchange energy and equalize, because the causal horizon, the distance over which light could travel and establish equilibrium, would have been vastly larger when the speed of light was vastly larger. The universe would be homogeneous not because of inflation, but because the early speed of light made it homogeneous the old-fashioned way, by actually connecting everything causally. The VSL program is not supported by any direct experimental evidence, and the theoretical framework has significant unresolved difficulties. I'm not telling you this because I think it is likely to be correct. I am telling you it exists because it represents a coherent scientific possibility that changes the interpretive landscape around the speed of light in a fundamental way. If the speed of light is a property of the quantum vacuum in its current ground state, rather than a fixed architectural feature of space-time, then the question of whether it can be bypassed takes on a completely different character. You would not be trying to break a structural rule, you would be trying to access a different state of the medium. The quantum vacuum is not nothing, it has properties. Those properties include the permittivity and permeability of free space, two quantities that together determine the speed of light through the relationship equals 1 over the square root of epsilon 0 times mu 0. If the vacuum state can be locally modified, and the Casimir effect demonstrates that vacuum energy can be locally modified by geometry, then in principle the local speed of light could in principle be modified. The scales involved are incomprehensibly different from anything current technology can access. But the principle is not obviously forbidden, and in physics, not obviously forbidden is the beginning of a research program. Against these three interpretations, a wall, a contract, and a coincidence, the 2024 result sits differently and means something different in each case. If the speed of light is a wall, the Fuchs solution is the first confirmed toehold on the wall surface. It proves that the wall has accessible territory on this side, that subliminal warp geometry is physically real and potentially useful, even if the wall itself cannot be moved. If the speed of light is a contract, the Fuchs solution is the first correctly cited clause that does not violate its terms. It is the first time the fine print has been read carefully enough to produce a physically sourced geometric configuration that exploits the distinction between matter velocity and metric velocity. If the speed of light is a coincidence of the current vacuum state, the Fuchs solution is the first piece of engineered geometry that treats the problem at the level of structure rather than speed, which turns out to be the right level of analysis regardless of which interpretation is correct. What threads through all three interpretations, the thing that does not change regardless of which picture of reality turns out to be accurate, is the central realization that this paper forces on the field. For 30 years, physicists working on warp drive physics were asking the wrong question. The question they were asking was whether the speed of light can be broken. The question they should have been asking, the question the 2024 paper implicitly answers, is whether space-time geometry can be engineered with physical matter. Those are not the same question. The first question is about a limit. The second is about a capability, and the capability question is the one that actually matters, because you cannot address the limit question at all until you have established the capability. The Fuchs result establishes the capability, at least in the subliminal case, for the first time. That shifts everything. Now I want to bring this somewhere concrete, because abstract interpretive frameworks are only as meaningful as the reality they describe. Think about a star, not a metaphorical star, a specific one, Alpha Centauri, the nearest star system to our own, sitting at a distance of 4.2 light years. 4.2 multiplied by the distance that light, travelling at 300 million meters per second, covers in an entire year. Light travels approximately 9.5 trillion kilometers in a year. Multiply that by 4.2, and you get roughly 40 trillion kilometers of empty space between our solar system and the nearest other one. 40 trillion kilometers of nothing, essentially, between us and the closest other place in the universe that might have planets, that might have warmth, that might have anything, at the speed of the fastest spacecraft humanity has ever launched. The Voyager probes travelling at roughly 17 kilometers per second, the journey to Alpha Centauri would take approximately 75,000 years. To put that in perspective, the oldest continuously inhabited city in the archaeological record is perhaps 12,000 years old. The entirety of recorded human history, every civilization, every empire, every technological development from the wheel to the semiconductor, fits inside a window of time that is less than 1/5 of the travel time to the nearest star with our fastest existing technology. We have not existed long enough, as a technological species, to make that journey with the tools we have. The distance to Alpha Centauri is not an inconvenience or an engineering challenge. It is, measured against everything we have ever built or done, an absolute barrier, not a speed limit, a wall of time. And now, on April 29th, 2024, a small team at a privately funded lab in New York published a paper that does not break that wall, does not remove it, does not make it irrelevant or easy or near. The bubble is subliminal, the solution is mathematical. The engineering challenges are formidable to the point of being generational problems at minimum. The gap between the equations and a working device is measured not in years or decades, but very possibly in centuries. All of that is true, and none of it should be minimized. But it is also true, and this is the thing that matters, that this is the first time the mathematics of physically sourced warp geometry has been allowed to say yes. For 30 years, every attempt to write down that mathematics produced something that violated physical law. Every single one. And on April 29th, 2024, one attempt did not. The equations looked at the configuration, evaluated it against every energy condition they contain, and returned a result that said, "This is allowed." We did not break the speed of light on that day. We did not open a wormhole or launch a warp-capable spacecraft or solve the problem of interstellar travel. What we did, what that small team in New York did by publishing that quiet paper in that specific journal, is something more subtle and more foundational than any of those things. We learned, for the very first time in 30 years of trying, how to ask the right question. And the universe, when asked the right question in the right mathematical language, answered in a way it had never answered before, not with a breakthrough, not with a promise, just with a yes, quiet, precise, and for the first time in a generation, real. We did not break the speed of light on April 29th, 2024. We may have learned, for the very first time, how to negotiate with it. And in the long history of humanity's relationship with the cosmos, learning how to negotiate has always been the first step toward learning how to travel. Extended reflection. The deepest question. There is one more layer to this story that most discussions never quite reach, and I want to spend some time here because it reframes everything we have covered in a way that I think is more satisfying than any of the individual pieces on their own. It has less to do with engineering or specific mathematical results than with what this kind of question reveals about the nature of physical law itself, about what we mean when we say the universe forbids something. Because embedded in that phrase, the universe forbids, is an assumption so deeply held that most people never notice it is an assumption at all. When we talk about the speed of light as a limit, we're implicitly assuming something very specific about how physical laws work. We're assuming they are prohibitions. We are assuming that the laws of physics say you cannot do this, and that the role of physics as a discipline is to map out the territory of the forbidden, to draw the boundary around the possible, and label everything outside it as unreachable. This is such a natural way to think about physical law that it feels almost definitional. Of course, the laws of physics are prohibitions. That is what makes them laws. If they were merely suggestions, they would not be doing much work. But there is another way to think about physical law that is equally defensible, that has deep roots in the mathematical foundations of physics, and that the 2024 paper implicitly illustrates in a way that I think is worth making explicit. In this alternative view, physical laws are not prohibitions. They are descriptions of what the universe prefers to do, given the available options and the constraints of the situation. They are the stationary points of an action, in the language of Lagrangian mechanics. They are the configurations that extremize some quantity, that minimize energy or maximize entropy, or solve a differential equation subject to boundary conditions. They do not say you cannot. They say here is what happens when the system is left to its own devices. Here is the path the universe takes when nothing is constraining it to take a different one. The difference between those two framings matters enormously, and not just philosophically. A prohibition is absolute. It is definitional. It applies regardless of conditions, regardless of context, regardless of what clever arrangement of matter and geometry you might construct. You cannot exceed the speed of light the way you cannot construct a four-sided triangle. The thing you are trying to do is internally inconsistent with what the words mean. A preference, on the other hand, is a description of what occurs in the absence of special conditions. It describes the natural, unengineered behavior of a system. And special conditions can, in principle, be created, not to break the preference, not to violate the law, but to satisfy it in a different way than it would be satisfied if you simply let nature run its default program. The law is still obeyed. The solution is just a different one than the obvious one. Warp drive geometry, viewed through this lens, is not an attempt to break the speed of light. It is not a violation looking for a loophole. It is an attempt to satisfy the equations of general relativity in a way that produces directed metric expansion, using physical matter, in a configuration that solves those equations completely and correctly, but that had not previously been identified as a valid solution because nobody had looked in the right part of the solution space. The speed of light is still there in the Fuchs solution, causality is still there, the energy conditions are still there, nothing is being violated. What has been found is a new solution, a configuration that satisfies all the constraints simultaneously in a region of the mathematical space of possibilities that was previously assumed to be empty, because every attempt to map it produced configurations requiring exotic matter. The constraint space was always the same, the map of solutions was incomplete, the law was never broken, the solution was just unfound. This is, when you step back and look at it clearly, what scientific progress almost always looks like. Not the discovery that the rules were wrong, but the discovery that the rules have solutions we had not found yet. Solutions hiding in parts of the mathematical landscape we had either not looked at carefully or had prematurely dismissed. Newtonian mechanics was not wrong when Einstein published special relativity in 1905. It was incomplete. It was the correct description of a limiting case, the case where velocities are small compared to the speed of light, and the discovery of special relativity did not demolish Newtonian mechanics. It revealed it as a subset of a larger truth, valid within its domain, insufficient outside it. Special relativity, in turn, was not wrong when Einstein published general relativity in 1915 and 16. It was the special case that applies when spacetime is flat, when gravity is absent or negligible, and general relativity extended the framework to include curved spacetime without invalidating anything special relativity had correctly described. Each step did not demolish the previous understanding. It revealed the previous understanding as a subset of something larger and more complete. General relativity may be next in that sequence. It may not be wrong. It may be the classical limit of a deeper quantum theory of gravity that we have not yet fully written down, a theory that reduces to general relativity in the regime where quantum effects are negligible, the same way general relativity reduces to special relativity when spacetime is flat. The 2024 paper does not demolish the physics of the last century. It does something more modest and more meaningful. It reveals a subset of general relativity's own solution space that has been sitting there, valid and consistent and physically sourced, unmapped for 30 years because the field was looking for solutions in the wrong region and kept finding the same dead end. The rules did not change. The map got bigger. What lies at the edge of that newly expanded map, in the region where subliminal warp geometry approaches the causal boundary at the speed of light, is where the most interesting physics of the coming decades will be done. And I want to be specific about what interesting means here, because there are several distinct technical questions that are now open in a way they were not before, and each one is a genuine research frontier rather than a speculative daydream. The first question is whether there is a continuous family of solutions extending from the Fuchs result toward light speed, maintaining physical sourcing throughout. The Fuchs solution exists at a specific subliminal velocity. Does the solution space contain nearby solutions at slightly higher velocities? Can you trace a path through this parameter space of warp bubble geometries from the current result toward the speed of light boundary, always maintaining the energy conditions, always staying in the physically sourced regime? Or is there a sharp cutoff at some velocity below light speed, where the energy conditions can no longer be satisfied with physical matter? That is a precise mathematical question, and it is now a question worth asking because there is a known starting point from which to begin the search. The second question is how the energy condition requirements change character as velocity approaches light speed. In the Fuchs solution at subliminal velocities, the conditions are satisfied, but physical intuition, informed by the Everett-Visser analysis of causality violations, suggests that something must change as you approach the threshold. Does the energy required to maintain the shell diverge as velocity approaches light speed? Does the geometry become progressively more sensitive to perturbations? Does the stability of the shell degrade continuously or abruptly? These questions are not answered by the 2024 paper. They are opened by it. The third question is whether the chronology protection conjecture enforces itself as a sharp boundary in the combined solution space of Einstein's equations and quantum field theory, or whether it is a soft boundary that admits gradual approaches. Hawking's conjecture, as we discussed, is not a proven theorem. It is a physical intuition backed by divergence calculations in specific scenarios. Whether it represents an absolute wall at light speed, or a region of increasing instability that becomes insurmountable at the threshold, is a question that requires a more complete theory of quantum gravity to answer definitively. We do not have that theory yet, but the 2024 paper gives us, for the first time, a position from which to begin asking the question empirically, rather than purely theoretically. These are not philosophical questions dressed in technical language. They are technical questions that happen to have philosophical implications, and they are now being asked from a position of at least partial success, rather than complete theoretical stagnation. That is a fundamentally different posture for a research program to occupy, and the difference between asking a hard question from a dead end and asking it from a confirmed foothold is the difference between wandering and navigating. The universe has been running the geometry this paper describes since the very first instant of its existence. Cosmic inflation, the period of superluminal metric expansion in the first fractions of a second after the Big Bang, is the largest and most powerful warp-like event in the history of the cosmos, and it required no engineering whatsoever. It happened because of whatever the quantum vacuum was doing in those first extraordinary moments, when the universe was young enough, hot enough, and strange enough to undergo that kind of expansion naturally. The geometry was not designed. It was not sourced by any civilization. It emerged from the initial conditions and the physics of the quantum vacuum in a regime we do not yet fully understand. If that event was possible, and it was, we are inside its aftermath right now. If the universe itself can undergo superluminal metric expansion as a natural phase of its own evolution, then the question of whether a small, localized, deliberately directed version of that expansion is achievable by a technological civilization is not a question about whether the physics permits it. The physics already demonstrated it, at a scale that makes every human ambition look like a child's sketch next to the blueprint of a continent. The question is something more specific and more interesting than permission. The question is whether intelligence can learn to read the instructions the universe has already written, not in any text or signal, but in the geometry of its own expansion from the first instant to the present moment, and apply those instructions deliberately, precisely, and at the scale of something small enough to carry a crew. That is the question the 2024 paper places on the table for the first time, not answered, not close to answered, but finally, after 30 years, correctly asked. Closing, the negotiation. There is something profound about the timing of all this, and I do not mean profound in the vague, overused way that word usually gets deployed at the end of science videos. I mean it in the specific, almost disorienting sense that we're sitting at a genuinely unusual intersection of moments. We are at a point in the history of space exploration where the nearest star feels closer than it ever has, not because we have made any literal progress toward it, not because our rockets are faster or our propulsion systems more capable, but because for the first time in a generation, the mathematical framework that might eventually allow us to reach it has produced a result that does not immediately collapse under scrutiny. That is a subtle thing. It is easy to miss. But if you have followed this story from the beginning, you understand why it matters in a way that is almost disproportionate to how quiet the result was when it arrived. Every previous attempt to build on Alcubierre's 1994 framework ran into the same wall. The geometry was always real. The sourcing was always fictional. Every warp bubble solution that anyone published in the 30 years between Alcubierre and Fuchs was either mathematically consistent but physically impossible, requiring exotic matter that does not exist, or physically motivated but geometrically inadequate, failing to produce the directed metric expansion that a genuine warp drive requires. The field was trapped in that contradiction for 3 decades. Real geometry, fictional matter. Real matter, no geometry. The two halves of the problem refused to come together. Every small thing that looked like progress turned out, on closer inspection, to be real in one sense and unphysical in the other. The 2024 result is the first small thing that is both. Real geometry and real matter simultaneously in the same solution, evaluated against every energy condition that general relativity provides, and passing all of them. That is the first time that has happened. Measured against the distance to Alpha Centauri, against the 40 trillion kilometers of empty space between us and the nearest other star, it is a vanishingly small thing, a mathematical result, a configuration in an equation. But measured against the history of this specific problem, against 30 years of every attempt producing the same fundamental failure, it is the only kind of small thing that has ever mattered. It is the proof that the category is non-empty. It is the existence theorem. And existence theorems, in physics as in mathematics, are the foundations on which everything else eventually gets built. What does it actually mean to say the math is no longer forbidden? It means that the universe has been asked, in the most precise and unambiguous language we have available, whether a physically sourced warp bubble can exist within the framework of general relativity, and it has answered yes. Not loudly. Not with a press conference or a headline or a demonstration that you can point to and say, look, there it is, just yes. A quiet affirmative returned by the equations to the people who knew how to ask them correctly. In a journal that 30 years ago published the question in Miguel Alcubierre's original 1994 metric, and has now, in the same pages, published the beginning of an answer. There is a kind of completeness to that, a closing of a loop that feels almost deliberate even though it is entirely coincidental. The same journal, 30 years apart, the question and the first partial answer, bound together in the same publication record. The Fuchs paper does not break the speed of light. I want to say that one more time clearly because the title of this video asks a question that deserves a direct answer before we close. No, the speed of light was not broken on April 29th, 2024. The paper does not promise that the speed of light will ever be broken. It does not even promise that a subliminal warp drive, the slower-than-light version that the solution describes, is achievable in any practical engineering sense within any timeline that any of us will live to see. The gap between a mathematical solution and a working technology is enormous in the best of circumstances, and these are not the best of circumstances. The energy requirements are beyond current capability by orders of magnitude. The stability questions are unresolved. The engineering of initiation, termination, steering, and habitability has not been touched. All of that is true and should not be minimized. What the paper does is something more precise and in some ways more important than breaking a speed limit. It changes the character of the conversation. Before April 29th, 2024, the conversation about warp drives was the conversation about whether the impossible could be made possible. That is a very specific kind of conversation, and it is an exhausting one, because it requires you to argue simultaneously about physics and about ontology, and about what counts as evidence, and about whether the category you are discussing is even coherent. It is the conversation you have when you're not sure the ground exists. After April 29th, 2024, the conversation is about whether the possible can be made practical. That is a completely different conversation. It has a different emotional texture, a different set of tools, a different relationship to progress. Physics knows how to have that conversation. It has been having it successfully for centuries. It knows how to take a mathematical proof of possibility and turn it eventually through iteration and refinement and experiment and engineering into something real. It has done it before in domains that looked far more intractable than this one at their respective starting points. Now let me give you the scale, because I think it is important to sit with it rather than abstract it away. Alpha Centauri is 4.2 light-years from Earth. 1 light-year is the distance light travels in a year, moving at roughly 300 million meters per second, which works out to approximately 9.5 trillion kilometers. Multiply that by 4.2 and you get roughly 40 trillion kilometers of space between our solar system and the nearest other one. 40 trillion kilometers of essentially nothing. The Voyager 1 probe, the most distant human-made object ever launched, is currently about 24 billion kilometers from Earth, which sounds impressive until you realize it is roughly 1/600th of the way to Alpha Centauri. Voyager 1 launched in 1977. It has been traveling for nearly 50 years, and it is 1/600th of the way to the nearest star. The light from Alpha Centauri that is arriving at Earth right now left that star 4 years ago. It has been traveling for 4 years at the maximum speed the universe appears to permit, and the journey it has completed is, in the context of our own galaxy, approximately equivalent to the distance from your front door to your neighbor's mailbox. The Milky Way galaxy is 100,000 light-years across. The nearest large galaxy, Andromeda, is approximately 2.5 million light-years away, close enough that it is visible to the naked eye on a clear night as a faint smudge of light, and yet so distant that the light you are seeing left it 2.5 million years ago, before our species existed. The observable universe, the sphere of space from which light has had time to reach us since the Big Bang, is approximately 93 billion light-years in diameter. On that scale, Alpha Centauri is not the frontier of human exploration. It is the driveway. It is the first step off the porch, and right now, with everything we have built and launched and aimed at the sky, we cannot reach the driveway in less than 75,000 years. That is the context in which this paper matters. Not because it solves the problem of those distances. It does not. Not because it promises a solution. It does not. But because it is the first time in 30 years that the mathematical framework which might eventually address those distances has produced a result that is both geometrically valid and physically sourced. And those two things have never been simultaneously true before in this field. If there is a way, somewhere in the deep architecture of physical law, to negotiate with the speed of light, rather than simply accepting it as the permanent ceiling of human ambition, then the paper published on April 29th, 2024, is the first document in that negotiation that has been signed by both parties. By the humans doing the asking, and by the physics providing the answer. For the first time, both signatures are on the page. We have not broken anything. We have not transcended anything. We have not solved the problem of interstellar distances or defeated the tyranny of light speed, or opened a portal to the stars. What we have done, what that small team at that small privately funded lab did by publishing that quiet paper in that specific journal, is find a place for the first time in 30 years where the equations that govern the universe look back at the people questioning them and return a result that says, this is allowed. That's a small thing by almost any measure. It is also, in the history of this particular question, the beginning of everything. Every technology that changed the human relationship to distance, from the sail to the steam engine to the aircraft to the rocket, began with a moment when the physics stopped saying no. This might be that moment for the largest distance problem our species has ever faced. The question is no longer whether we can break the speed of light. That question has a complicated answer that depends on what you mean by break, and what you mean by light, and what you mean by the kind of universe we are living in. The question now is which universe we actually inhabit. A universe where the speed of light is a wall, absolute and load-bearing, and the subliminal warp bubble is the best possible toehold on its surface. A universe where the speed of light is a contract, with fine print that geometrically sophisticated engineering might eventually learn to cite correctly. Or a universe where the speed of light is a feature of the current state of the vacuum, contingent and local, and the real question is what happens to the rules when the medium changes. Those three universes look identical from where we're standing right now. The physics we have cannot yet distinguish between them, but for the very first time the mathematics is alive enough and grounded enough in physical reality to help us start finding out. Space has always been the loophole. The universe demonstrated that in its first fraction of a second, when it expanded at rates that make any human conception of fast look like standing still. We have just found, in the pages of a quiet paper, that the world mostly scrolled past the first door. We do not yet know where it leads. We do not know how wide it opens. We do not know if the hallway beyond it goes all the way to the stars or ends somewhere short of them in a wall we cannot see from here. But the door exists. The math says so. And for the first time in 30 years, the math is allowed to say it.